Hola, buenos días. Sean todos bienvenidos a este seminario. ¿Me pueden confirmar por el chat si se escucha el audio? Perfecto. Ok. Buenos días a todos. Bienvenidos a este seminario enfocado en el Flow Solution. En este día nos acompañan nuestros partners OI Analytical, los cuales nos darán una introducción y una temática dentro del tema. Comenzaremos con Giovanna para introducirnos al ponente del día de hoy, Han Hack. You can start now, Giovanna. I stop share.
Okay, thank you, Jesus. Let me share my screen. Mm. Okay, let me see. Okay, can everybody see my screen?
Yes, we can see.
Can you see? Okay.
Yeah.
And you can hear me also. Okay, excellent. Okay, so good morning, everyone, and welcome to today's presentation on automated chemistry analyzer applications, methods, and technology. My name is Giovanna Esposito, and I am the Latin America Sales Manager for the Lab Solution vertical for Xylem Analytics. Today, we will introduce you to Xylem and OI Analytical, followed by the presentation on automated chemistry by Mr. Hank Han, the Senior Product Specialist for OI Analytical Technology. Xylem is a global water technology leader who works with customers to solve the most critical water and resource challenges. Xylem has more than 17,000 colleagues around the world with diverse water expertise, along with the presence and operation in 7 continents. Our products are sold in over 150 countries. We move, measure, analyze, and treat water. We partner with customers to solve their most important water challenges. Our solutions span through the entire water cycle. We bring together advanced technologies, applications expertise, and smart, sustainable solutions. Measurement and control is a segment of Xylem with a revenue of approximately $1.4 million and more than 400 employees. OI Analytical is a Xylem brand and part of the measurement and control solution segment, with offices in College Station, Texas, and with manufacturing facilities in Yellow Springs, Ohio. OI Analytical designs and manufactures instrumentation for chemical analysis. Data from our analytical instruments serves as the basis for informed decisions affecting human health and safety, environmental protection, industrial operations, and product quality. OI Analytical was established in 1963 and entered the analytical instrument market in 1969 with the first TOC analyzer, the ampule-based method developed by Dr. Alan D. Fredericks. In 1980, OI Analytical developed the automated TOC model 700 with PPB detection capabilities. In 1986, OI Analytical introduced the first generation Purgeon trap technology with the patented direct resistive trap heating and water management fitting. In 1996, OI Analytical acquired Outcome, the leader in continuous flow analysis. In 2008, OI Analytical places TOC technology, the TOCA analyzer, on the International Space Station, the NASA project. In 2011, OI Analytical was acquired by ITT Technologies, from which later Xylem emerged from its spin-off of the ITT Fluid Division of ITT Corporation. In 2021, OI Analytical manufacturing processes moved to Yellow Springs, Ohio. In 2022, completed the merger of the OI Analytical brand into Xylem Analytics North America, which is in Yellow Springs, Ohio. The OI Analytical product portfolio includes total organic carbon analyzers, gas chromatography, purge and trap, and selective detectors, such as pulse flame photometric detectors, halogen-specific detectors, electrolytic conductivity detectors, and tandem detectors. Also, automated chemistry analyzer, the FS3700. And on the process side, OI offers the 9210P online TOC analyzer for drinking water, municipal wastewater, surface water, groundwater, and other industrial water streams. It is notable to say we have a new model coming analysis. Here you see some images of the College Station, Texas location, and the Yellow Springs location in Yellow Springs, Ohio. And now I'd like to present to you Mr. Hank Hahn, the Senior Sales and Product Specialist for OI Analytical. Mr. Hahn is based in College Station, Texas, which is approximately 100 miles west of Houston. Mr. Hahn has more than 30 years experience with analytical instrumentation, including product lines for gas chromatography, automated flow chemistry, and TOC analysis. Mr. Hahn's sales colleagues refer to him as a valued resource, as he provides a wealth of information in not only understanding the technical side of OI analytical instrumentation, but also understanding how it best provides solutions for various applications in numerous industries. So help me welcome Mr. Hank Hahn. And I will now stop sharing, Hank, and I will turn it over to you.
Okay, thank you, Giovanna, for the warm introduction, and good day, buenos dias, everyone. Give me 1 second to get set up here as well. Got stuff on my screen here. Excellent. Okay, so today what we'll be covering is, as Giovanna mentioned, the FS3700 and automated chemistry analyzer analysis. This will be an overview with applications, methods, and technology. So today what we'll cover is the OI Analytical Xylem technology, the FS3700 overview, and then also go over some of the methods we have. This is going to be of an environmental style based presentation with that kind of markets, looking at the drinking water and wastewater applications. What we have here is the FS3700, and it is an advanced continuous flow analyzer designed to improve laboratory productivity by automating the wet chemistry test procedures. The product was designed to have in mind the flexibility and capability to meet analytical needs. It's plug and play technology. It features high sample throughput with a low cost of ownership, robust technologies to meet demands of every type of sample matrix, and it has excellent precision and accuracy and regulatory compliance to ASTM, US EPA standard methods, and also the International Standards Organization. Some of the automation that we did with the FS3700 and components that we had put into it to make it a little bit better instrument than our prior ones is we have an 8-port flow injection valve installed here, required to run with any of the flow injection methodologies that we offer. We have a chemistry cartridge and chemistry plate, as we like to refer to it, that's pre-assembled with all the components needed to perform the chemistry. You just attach the pump tubing, your reagents, and the detector flow cell, change out your filter that have for the different chemistries, and away you go. By ordering the channel, it provides a convenient way to configure. Again, modular, flexible hardware provides a great platform for research, in-house or proprietary methods that you'd like to run. We have inline devices for reactions requiring the heating or the UV digestion under the chemistry plate. So this is a picture of a chemistry plate for the total cyanide, and that is the UV digestion lamp that you see there, and how we perform the total cyanide, removing the distillation step. We have the photometric and ampermetric detector modules. They plug into the FS3700 to support the methods employing the colorimetric methods with the photodiode lamp and the filter specific to the chemistries. And then we have the ampermetric detector, which is specific to the cyanide methods. So we put years of knowledge and such in this product from our prior associations with the Alchem product, the Perstorp, our CN solution, the 3100 and Flow 4. What's unique about our platform is you can have the ability to run a segmented or flow injection method on the same box. We have a very user-friendly interface called WinFlow software that we used to have, and now we incorporated that into the FlowView software. And it's nicely laid out, and we'll see that a little bit further in the presentation. We have the capability to run with Windows 10 and Windows 11. It connects via USB, and it can run from a computer or a laptop. We have quite a bit of chemistries available for this instrument. We've got all the different cyanides. You've got ammonia TKM by gas diffusion. That allows you to eliminate the distillation step as well. We have ammonia phenate nitrogen, your nitrate nitrites by via or segmented flow, phosphates in all forms, the phosphates low level. We have phenols, chlorides, sulfate. We also do the cyanide ISO methods and post-distillation method. We've got total nitrogen and total phosphorus, also working on some other chemistries as well, sulfide and silica. So the chemistries available that we've released were made to a best method and selected from the configurations developed with the previous generation of instruments. Again, everything comes standard. So this is a top view of a channel where you're seeing the flow injection valve, the chemistry plate, then our photometric detector in the back channel, and the front channel is the ampermetric setup with a gas diffusion module for cyanide. And again, we really want to stress modular, flexible platform. These plates can easily lift out and be replaced. We have a choice of auto samplers. We have 180 position and we have a 360 position. We use the Teledyne CTAC sampler with our instrument, as CTAC is well known within the industry for auto samplers. The typical one that we quote is the 180 position. You get two 90 position racks, or you can do 260 position. You've got 10 positions for standards. We have a rinse station. The instrument includes an onboard peristaltic pump, and you get the sample probe kit, and that includes everything for the probe and the XYZ drive. We use an Ispitec 24 channel pump. And what's nice about the 24 channels is that if you're doing multiple chemistries, you can hook them up with the platens, and you can have those ready to go if you do switch out chemistries. Most chemistries average 4 to 5, 6 pump tubes. So with the 24 channel capability, you do have the chance to add additional setup for you. And it goes on a principle of rollers, cams, the peristaltic tubing. It acts like a check valve in the pump, keeping the liquid flowing smoothly in one direction. It offers repeatable and consistent flow with each revolution. So here's the 24 channel pump with the platen and the platen extender. So this is an example of the platen. We have the pump tube that fits in, the pump tube collar that snaps into the platen extender, and can change those out quite quickly. Someone fortunately sat down and looked at the different internal diameter and flow rates of the pump tubes that are used by the varying chemistries. So just included this to kind of show the multiple pump tubes that we do use. And here's an example of pump tubes used in the ammonia TKN application. You have the orange green for air injection. You have yellow yellow for sample pull. You have black black for debubbler pull. Ammonia TKN is done by segmented flow, so that's why we do have a debubbler that eliminates the bubbles before it hits the detector. Then we have also gray gray and orange yellow to help with the different reactions and additions of the reagents to make that color. So what's in a channel? And again, that's everything you need to run your chemistry. On the colorimetric side, we don't include the reagents. On the cyanide ampermetric side, we do, because some of those are proprietary. So again, breakdown of a flow injection valve, the chemistry plate, and the specific detector for the chemistries that you do. And this one setup is, again, with ammonia, TKN, and a then cyanide. Those two chemistries are extremely popular in the fact that these were developed and approved by the EPA back in 2012 to eliminate that kind of tedious distillation step. Here's a breakout of the colorimetric chemistry by a side view. So if you're using a chemistry that requires flow injection, we do have the FIA valve, your chemistry plate. It's got the mixing coils, air teas, whatever necessary for that reaction. In the segmented flow, we have a debubbler. We remove the bubble before it does enter the lamp. There we have the photometric detector, which includes the filter specific to the chemistry. The lamp is easy to replace. It sits right on top of the one detector cell right here, and 2 set screws, and you can take that out and easily replace that. So here's a breakout of what's in an ampermetric cyanide chemistry. Those are done strictly with flow injection. And again, as I mentioned, with ampermetric detection. Your chemistry plate with the required mixing teas and pump tubes for the reaction. We use the gas diffusion module. Again, we're eliminating the distillation step. With our total cyanide, we use the UV digestion lamp to help break down those bonds. And then you've got the ampermetric flow cell with the reference electrode. With our ampermetric cyanide, and again, that's with the cyanide chemistries, it's the best detector for the ampermetric style techniques on the market. We redesigned it on the FS3700 to reduce noise. It's not a third-party detector. This is our own. It's improved flow cell and upgraded electronics. And it's also made up of reference electrodes. Red is the working electrode, reference electrode is red, working electrode is white, and the counter electrode is black, which then closes the loop. With our photometric detector, it was known previously as a 550 detector. Also, with the expanded range detection, we have a 10x increase in signal noise for some of the methods, also allowing you to go and do low levels like the low level phosphorus. We've improved the detection limits from the FS3100 with this detector. The MDLs down to low part per billion limitation is now the flow noise. At point, it does eliminate the need for auto dilution because we do have 4 orders of magnitude with the wide range capability of this. We do offer a diluter, RML 600, and I have a little bit of information on that in the presentation. We did some work with the expanded range detector with the sensitivity. It can detect very small changes in the signal without increasing the gain. And this allows for detection of low concentrations. The photometric detector allows the sample stream to flow through the detector required for the flow chemistry. As the sample flows through, you'll see a peak rise on the graph with our flow view software. After the sample passes through, the peak will settle back to baseline until the next sample begins to flow through the flow cell. The peak is compared to the calibration curve, and a result is calculated against that curve. So here's a little breakdown of the detector as well with the lamp. And we ship standard with that a 5 millimeter flow cell. The low level phosphorus uses a 20. We offer 10 and 15 as well, and very easy to change out and replace, and also to clean as well. So this is a breakdown of that photometric detector. Again, as I mentioned, we do 5, 10, 15, and 20 millimeter are available. The lamp, and then under the plate is the nanometer filter and the housing. And as I mentioned, this is where everything coalesces, and the results of the sample collection, reagent preparation, and instrument operation come together to produce the final analytical conclusion. And as I mentioned, the detector allows for flow cell windows to be removed, cleaned, or replaced if required without the costly replacement of the entire flow cell. We did some refinements with the expanded range detector as well. We did start out with a 10 position FIA valve, and then we found with an 8-port valve plumbed utilizing a bypass loop equal to the size of the injection loop, alleviated pressure differential and reduced detector noise related to the valve actuation. So by going to the 8-port valve, these bypass loops, we reduced noise as well. Now here's a layout of the FlowView software. As I mentioned, it's a really nice, easy layout, sort of like your Apple products. You've got configure analyzer, build your method, build your sample table, run your samples, view the results, and we also have a perform maintenance screen as well. Very intuitive software, 32 and 64-bit, Windows 7, 8, 10, 11. We recommend the Pro version. It performs dynamic auto scaling, keeping analytical peaks on scale over that large dynamic range, as I mentioned, 3 to 4 orders of magnitude with the photometric detector. We allow for you to view and edit results in real time. And we also have easy LIMS import, table, and export configurations. And you can reprioritize or edit the sample table on the fly during analysis. So say, for instance, you have like an emergency sample, it's a Friday and someone needs something run, you can immediately, after a sample runs, you can hit the stop, load that into your sample table, and run that sample. The FlowView software has a launch screen where you set up your instrument, COM ports. It's easy to add the system, click add, appropriate name, and we typically name these units by the serial number of the instrument. And then you can move on to configuring the analyzer. In this screen here, you can set up your detectors, your chassis, your sampler. You can choose the photometric, ampimetric, channel 1, channel 2. In your flow view build method, here is where it's divided into 4 sections that allows you to define the method and the calibration parameters assigned for each channel. So there's calibration table, the actual calibration, your signals and peak marking, and then your quality control. You can define the concentration and ID for all the calibration standards in the calibration table. And you can highlight a channel, then choose a curve, fitting method, and concentration units in the calibration. With our signal, peak marking, and quality control, you can configure peak quantification, height and area, baseline, smoothing, and sync peak identification parameters. In the quality control, we have the ability to set up 13 different quality control sample types. So here is an example of building the sample table. You see here that we're setting up and building a sample method. There's all these different icons here on the side where you can add the sample, view, build your table. In this, we've set up a sync, a blank, carryover, baseline, and we're using 0.1 to 5 ppb, and then running your standards, and then a blank, clearing that out, and then setting up your sample table, and then another blank. You can also set up like a wash after a run if you think you might have like a really kind of nasty sample, prevent any kind of carryover or anything along those lines. And at the end of the run, you can also set up a wash as well. And this is again building the sample table. And then upon that completion, you can run the samples, the run sample screens, control sample sequence, and monitor data as collected. You can look at channel 1 and then click over to channel 2. You can split the screen and watch both channels as well. You can view the calibration, view results, and then also press all channels to display a split screen, as I mentioned, of all the detector signals and sample peaks. So you can monitor this in real time. The view results screen allows you to review the data. It may be reviewed from active or the completed sequence. And here's a review results example. You can export the results, as mentioned. And then you can choose the parameter of your results as well of what you'd like to include in that. We do have the maintenance screen, as I mentioned. It's really nice little addition. There is a little button that you can click that is a self-test that will put the instrument through a self-test, or you can go through each item here. And what's really neat too about this is we have a diagnostics feature right up here in the upper right, where you can enable the debug log, and you can then send that to our technical support team, and they can review that and look to see what kind of potential problems you might be experiencing. And I mentioned here's the self-test. It'll go through the detectors, heaters, UV lamp, if that's part of the configuration, check your valves, relay, auto sampler, and pump status. Some additional features is the sample import table from a CSV file. It's a full screen GUI, so it will fit into any size monitor. You can also do split screen as well with this, so it's really nice. As I mentioned, you do have the ability to pause, resume, and run between samples, emergency samples, and we support multiple languages as well: English, Chinese, French, and Spanish. So we did launch last year our ML600 diluter. We partnered with Hamilton, as they're one of the best in the industry in providing dilution capability and instruments. So we have a dilution range of 1 to 1.5 to 1 to 1,000. We use stepper motors with an optical encoder. It is a dual syringe. Your dilution syringe can be 5 or 10 mil, and sample syringe is 0.100 mils, 0.250 mil, or 500 mil. So it's available as the add-on with the FS3700 built into the software. Our version 2.0 software supports this platform. So this will allow you to adjust calibration ranges, sample dilution factors. It includes the diluter. We use a Valco 4-port two-way valve with an actuator to help move that from the dilution over to the sampler and 3700. It'll work with both 3180 or 3360, controlled via the flow view. It can make sample calibration standards as well from a single stock standard. And that's really what a lot of folks appreciate about this. Automated dilution of overrange samples and predetermined sample dilutions. And these factors will eliminate need for time-consuming reruns of overrange samples, increasing your lab's productivity and reducing costly downtime for the clients. Some of the features, as mentioned, it provides generation of calibration standards, increases precision, accuracy, and reproducibility versus manual. Provides automated pre-dilution of known overrange samples. You can use that as a user-defined dilution factor. Provides automatic detection, dilution, and rerun of overrange samples. Generates dilution factors for overrange dilutions based on sample. Rerun of followers after overrange samples. Ensures that the following samples are not adversely affected by overrange. Provides automated CCV-based sample table updates to it as well. And one of the neat things about the ML600 is our applications chemist, Mr. Tim Smith, always liked to make his own calibration standards and such. And when he started using the ML600, he was greatly impressed and raves about this apparatus. So we'll do an overview of the Xylem method laboratory as well, library that we have. And as well, we'll talk about why do environmental labs do these testings. The commercial labs analyze for profit, and municipal labs analyze for the process control, satisfy permit. Industrial labs satisfy permits. And been doing some different kind of research on the different industries involved with these specific chemistries. So who does the testing? We know there's national lab chains, there's independent laboratories, there's municipal, industrial, petrochemical, chemical, universities with research, mining, plating, USGS, USDA labs here in the United States that were real big. And Latchet is a competitor who's leaving the marketplace, and that was really big in government facilities. There's like the regulatory agencies here in the United States. We've got the EPA with their Clean and Safe Water Drinking Acts. For the wastewater, there's the Protection of Environment Part 136 for wastewater, 141 for drinking water. Also, MPDS permits, where regulating point sources that discharge pollutants to waters in the United States. This program makes sure that if you're using water in any kind of process, that you're putting it back as you found it and being treated, and you test it prior to the effluent release. And there's here in the United States, a big effort with the National Pollutant Discharge Elimination System administered by the EPA. Why the testing? There's the different ASTM D19 committee that is specific to water. There's standard methods for examination of water and wastewater, the SM4500 series. There's the ISO methods. They're big on cyanides as well, MBAS. And also we've developed some stuff with nitrate, nitrite in milk, powdered milk, baby formula, monitoring for nitrate, nitrite in that. So here's a purpose of some of the testing of the chemistries. You've got ammonia, nitrogen. They are mostly going to be seen in your wastewater, your testing in your drinking water. There's your TKN, that's organic nitrate, includes proteins, nucleic acids, and urea. High nitrogen content indicates fertilizer or sewage contamination. And you'll see that a lot with all the chemistries here specific to like ammonia, your TKN, your nitrate, nitrite, and your phosphorus. Same here with the nitrate, nitrite. And then with ortho and total phos. Phenol is a common ingredient of disinfectants. In drinking water, low-level phenolic can impart a foul taste or odor, especially upon chlorination. Also, BPA testing solutions in bottles, the plastic bottles and such, to make sure that it's BPA free or extremely low levels of that. It's a chemical of concern that's been found in plastic food, beverage containers, and one of the really big things was the baby bottles as well. And the most common pollutants in ground and drinking water are essential to monitor, because the depletion of groundwater resources and continued decline in overall groundwater quality is a cause of concern, because large human population around the world uses groundwater as a source of their drinking water. Studies have documented the incidence of groundwater pollution from various anthropogenic activities, such as improper discharge of industrial and municipal wastewater, application of recycled wastewater for irrigation purposes, mobilization facilitated by subsurface geochemistry, and seasonal changes as well. And especially since we're in the heat of summer, you do see the algal blooms appear more often during this time frame. The release of nutrients have resulted in large dead zones here in the United States with the Mississippi River. You've got a lot of agriculture that is all around the states, and that ultimately gets into the river, ultimately then dumps into the Gulf of Mexico, and that's where you see hypoxia and the dead zones And unfortunately, you see the fish kills and such that happens with that, kind of known as red tide. So the biggest ones for monitoring, of course, are your nitrate, nitrites, your ammonias, your TKNs, and your OFOS. Nitrogen and phosphorus account for about 80% of analytes measured by automated chemistry analyzer. Well over half of those analyses are for the simple nutrients, your ammonia, nitrate, nitrite, and the phosphates. The remainder is total nitrogen and phosphate, either by Keldol digestions or persulfate. Now, also been doing a little bit of research with these in the environment, and a lot of these discharges and sources can come from municipal wastewater plants. It's ammonia is generated from the breakdown of proteins and urea present in domestic sewage. There's also your industrial wastewater that's coming from fertilizer plants, refineries, coke plants, and other industries that can contain very high ammonia levels. Animal and agricultural waste lagoons that can have high ammonia discharges. Overflows or leaks from feedlots or manure storage areas during heavy rainfall events can discharge significant untreated ammonia. And landfill leachate can have ammonia concentrations of hundreds to thousands of milligrams per liter, because the municipal solid waste contains organic waste. So if that leachate escapes those collection systems, it can pollute groundwater and surface water. With regards to nitrogen, again, wastewater treatment plants can discharge nitrate in their final effluent. There's the fertilizer industry as well with that. Runoff from the agricultural fields, animal feedlots, manure storage, again, landfill and leachate as well in ammonia and nitrate, due again to the organic breakdown. Nitrate is regulated in wastewater and drinking water due to concerns over algal blooms. And then, as I mentioned, there's also blue baby syndrome from ingestion of high nitrate water in drinking water. And finally, with the phosphorus and orthophos, that can also be seen in human waste, food waste, laundry, cleaning products, industrial waste, again, from fertilizer, metal finishing, dairy processing, and other industries can have very high phosphorus concentrations. Runoff from agricultural land, applying manure or phosphorus fertilizer, the animal manure again, and overflowing lagoons. Detergents and cleaning agents can also be high in phosphates. It also, with release and why it's highly regulated, is it also creates algal blooms as well. So managing and treating these nutrient discharges properly is very crucial to avoiding environmental impacts on receiving waters. So these kind of slides right here represent a little bit what was characterizing with your ammonia, your nitrate, and phosphorus. And here it touches on with the nitrates. Here in the United States, we have like a consumer confidence report that is included with our utility bills annually. And so there are specific compounds that have to be monitored. One of them, as I mentioned, is nitrate. And again, it causes oxygen depletion in water, which leads to fish kills and then also health concerns with regards to that blue baby syndrome. In drinking water facilities with nutrient analysis, what's real big is free cyanide, nitrate, nitrite, nitrogen, nitrite, nitrogen, and orthophosphate, and all methods that we can perform with the FS3700. So here are the methods to monitor pollutants. We've got ammonium nitrogen phenate, and we have method abstracts that we have available that gives you a brief synopsis of what's happening in this analysis, any kind of regulatory bodies that we follow, and then we do a breakout of what's happening in the reaction with how you're using the different reagents. And also here you can count in how many pump tubes you're using by this right here. You've got carrier, complexing reagent, alkali, phenol, hypochlorate, nitroferric cyanide, and dilutant. We include the results. This one was run from 0.01 ppb, 0.05 ppb, and 1 ppb. Then also you get the graph and results with the calibration curve as well. So we include these in method abstracts and then also the methods. The method is basically the cookbook. Ammonia, gas diffusion, TKM by gas diffusion, eliminating that distillation step. As mentioned, with ESG, being good stewards to the environment, eliminating distillation in your distilling and heating caustic acids, the electricity required to heat distillation apparatuses. You've got hazardous waste then that you've got to dispose of with disposal fees and things. So by running it with gas diffusion, you can eliminate costly and not too environmentally friendly applications. Again, breakout of the TKN and gas diffusion results. You do have to still perform the digestion of the TKN samples prior to the analysis. And then a breakout of the graphs. So we have this with all the chemistries. Here's available cyanide, our ASTM D6888, and this is a nice chemistry to use in case you do have sulfide interferences. This includes a reagent that is the sulfide abatement up to 50 milligrams per liter. Anything above that, you do have to dilute the sample. So the D6888 and the OIA 1677 are sort of like cousins, except D6888 adds an additional pump tube and can help eliminate if you have a potential for a high amount of sulfide in that sample. Here's OIA 1677. This was our first gas diffusion method approved by the EPA back in 1999. So this has been around quite some time. We have D7511-12, and that is total cyanide, again, using gas diffusion and UV digestion. Excuse me. And this was launched in 2012 and approved. I do have an exciting slide in just a couple of seconds expounding upon the cyanide methods as well, with an additional regulatory body now approving these. We've got your nitrate nitrite, as I mentioned. You can do that by flow injection or segmented flow. Some states here in the United States require segmented, some require FIAS. That's why we broke this apart for folks. You do use a cadmium coil for the nitrate, and then your nitrite can be run without the coil, or you can just plumb around it. We've got phenol inline distillation with the distillation head And we also have phenol post-distillation as well. And that also follows an ISO method in the post-distillation chemistries. We've got all forms phosphorus. And then also too, by the all forms, you can configure that for total phos or orthophos as needed. The low level orthophos, and that's where we use a different sized flow cell as well in this to achieve the low detection levels. We have total dissolved nitrogen by segmented flow, and this is used for the determination of total dissolved nitrogen in drinking water, surface, domestic, and industrial wastes. So this is where we use UV digestion in replace of digesting the sample prior to running it. So we also utilize a gas diffusion membrane as well in this application. So we've got heat, we've got a digester, and we're running this over a dialysis module. And we have total phosphorus as well by inline UV persulfate digestion and flow injection. So this eliminates the distillation step for total phosphorus. And again, this is using heat, UV digestion. We use a combination of flow injection and segmented flow in this. As this again is one of the complicated chemistries. Both of these require a little bit more pump tubes as well for the setup, but these do allow you to eliminate the digestion step by doing inline apparatuses. I want to touch a little bit further on cyanide and ammonia by gas diffusion. As I mentioned, most popular configurations are these two together, again, as that eliminates that distillation step altogether. We've been well known for cyanide analysis going all the way back to the Alpchem days. So there's been different models from 3202, the 3000, the 3100, and now to the 3700. Alpchem Analytical have been the innovators in cyanide analysis. There are different methods and such to refer to. So I like to point out ASTM D2036 is the standard test methods for cyanides of water. So kind of joke around in this being a little bit of the Bible with regarding cyanide analysis. This is a real good reference point. You do have to purchase this from ASTM. They're not free. There's D7365, which is an excellent companion to this. It's the standard practice for sampling, preservation, and mitigating interferences in water samples for the analysis of cyanide. This does kind of touch a little bit on that D6888 that I was talking about with the interferences that can occur with this as well. So cyanide methods measure the various cyanide species. So we've got the free cyanide, which are the weak to moderately strong metal complexes. That is very easy to break apart with reagents and acids. Then we have the available cyanide, and then we go to the strong metal complexes with your total cyanide. And with these strong metal complexes, that's where we use these acids and the UV digestion to break apart those bonds to measure the total cyanide. Now, here's what I wanted to highlight is that standard methods in their recently launched 24th edition from December of 2022 now includes 4500 C, N, P, Q, and R. So standard methods now recognizes these methods. Standard method CN 4500 CMP applies to the D7237 free cyanide method. And then there is the Q, which follows the methodology for the EPA OIA 1677 and ASTM D6888. And then PR, is the one that now refers to D7511-12. So what's nice about this is there is another regulatory body that has approved and written methods for this. The Standard Methods 24th edition has an amazing cyanide chapter. Again, these have to be purchased directly through Standard Methods, and they do break out the definition of running it by standard method. So the nice thing about that is that here we have EPA regulatory approval, ASTM, and now Standard Methods approval for these unique applications. And all these applications, by the way, are run with our ampimetric detector. Break out a little bit about cyanide, again, the free and the difference between free and available to the total cyanide. Kind of touched on these already with the different reagents and the reactions and such. Breakout of the methods, we've got the 1677 available cyanide by ligand exchange and flow injection. This is like an example from our method where we break out with using the FIA valve, the detector with the reference electrode, and then you get the pump tube layout and the pump tube coloring as well. And then, as I mentioned, the methods are the recipe. Here below, you'll always see that what pump speed we're doing this at, the sample loop size, and that bypass loop size on our flow injection valve. And these are those loops that have spoken about that goes on the valves. D6888, sulfide, again, as I mentioned, is that known interference. It can be eliminated by use of complexing agents described in this method prior to the gas diffusion process that prevent hydrogen sulfide from diffusing. The reagent that's being used is the reagent TA2 SAR, which is used in total cyanide as well. So TA1 and TA2 are in total. So this TA2 breaks down that sulfide. And this is a breakdown of the method and the pump tubes. If you recall, as I mentioned, 1677 and D6888 are cousins, and the pump tubes are identical, except here's that addition of that acid. We've got that total cyanide by D7511 and now by that standard method as well. And so this breaks out a little bit about the description of it, uses the narrowband UV water radiation to decompose cyanide. Again, this is nice where you're eliminating that distillation step, lower labor costs, lower cost per analysis. You don't have to use those caustic agents to distill that. And a breakout of the total cyanide layout. And again, as mentioned, our notes on the setup. We also, in the methods, include some of the important consumables per chemistry as well, so you can have part numbers and ID for some of the critical key components to replace over a period of time. So the gas diffusion method for ammonia was approved in January 2012, just as long as with the total cyanide, they were done together. And so we utilize continuous flow diffusion that passes the ammonia through that membrane into an absorber solution that is automatically color developed and measured by the continuous flow analyzer method. So this allows for facilities with MPDS permits to use gas diffusion to test wastewater samples for TCAN and ammonia and Clean Water Act compliance. And again, as I mentioned, with the total cyanide, it's higher sample throughput, it's lower labor cost, lower cost of analysis, eliminates the distillation step. Also, it's environmental friendly as well. And we do have some white papers available on the total and the ammonia TKN with regards to wastewater analysis. So when you're looking at other folks' layouts, we want to talk about simplicity. So this is a picture of our ammonia TKN gas diffusion module. And then this is our module that we use for the cyanides. Easy to replace the membrane. It's got that kind of pull-up lock hinge there, and you can release that and change out membrane quite easily. So with this, you can eliminate and say farewell to distillations, get rid of that expensive glass in case anything breaks, and also get rid of those big old machines there with all that glass and tubing. So in closing, our available methods, again, we follow cyanide. We also follow post-distillation cyanide by the EPA method 335.4. If distillation is still required, that's run by a photometric detector. That's not done by ampermetric. We've got your ammonias, your nitrate nitrites, your phosphorus all forms, your low-level phosphorus, phenol. You can do inline or post-distillation, so you can do the distillation step. Your chloride, sulfate, silica, sulfide, and then also total nitrogen and total phosphorus via UV digestion, and that's in line, so you can remove some of the timely manual steps with those chemistries as well. And that concludes our presentation for today on the FS3700. And if you have any questions, we'll be happy to take them. Also, thank you very much for your time today. It's been a pleasure giving this presentation, and hope helped explain our instrument and chemistries a little bit better today for you.
Thank you, Hank. I think we have someone actually that raised their hand, Christian Marin. I don't know if he had a question. Let me see. Okay, Christian, did you have a question? Okay, I don't know. Okay. Christian, did you have a question? Okay. Okay. Let's see here. So we have from Jose, information is very important to know the industrial contaminants and municipal and I guess state government. Is that the question, Jose?
Igual recuerden que pueden hacerla en español y nosotros la podemos traducir sin problema.
Mm-hmm.
Yes, that is really important, is because as I mentioned, I've been playing around and doing some research on the how and the why, especially like with ammonia, your nitrate nitrites, they do convert to ureas, and was learning about in food production, pet food production, anybody doing kind of like flavoring and the colored flavors like caramel color and such, that has a lot of ammonia in that, and that can convert over into urea. So that's heavily monitored. Also, ammonia can be monitored by mining as well, with cyanide in the salts that are generated from the cyanide salts you do to leach the apparatus, the rock and such to separate gold. There are ammonia salts that occur there. And just recently in Canada, we had quoted a total cyanide ammonia system for them, and they're way up in the north part of Canada, and they're monitoring that as well. So ammonia comes in many different kind of forms, especially in the effluents, and so there's unique monitoring coming of the source from the point of entry and then the point of exit. So you want to make sure you have good, clean water coming in, and then using that in the process, treating it, it's going out in good fashion as well. So it's kind of interesting learning about the different things that ammonia, your nitrates, and your phosphates are in some of these processes.
Thank you, Hank. I don't see any other questions. So, but, you know, should something come up later, please get in contact with the team, our partner at Analitech. And they will get back to us, and we will get the information to you, whatever information you might need. Okay.
Well, thank you very much, Giovanna, Hank. Let me say something in Spanish. Como mencionaba Giovanna, van a recibir un correo y de ahí pueden llegar las preguntas que puedan aparecer posteriormente con respecto a la información. Al terminar el seminario, ya sea hoy o el lunes, estarán recibiendo una constancia de asistencia con lo que es la grabación del video y la información completa. De igual forma, pues tienen los contactos que estaremos compartiendo, y cualquier cosa, sin problema, estamos para servirles. Thank you very much, Ivana. Hank, thank you for the webinar.
Thank you, Jesus. Thank you for having us. Thank you.
Thank you.
Have a
Bye-bye.
nice day.
Bye.
Bye.